So this section 8.6 is called power series, and so far we haven't used the term power series. So let's define what we mean when we say power series. So a power series centered at A is a function that can be written in terms of a series, and that's really it. It has to have this special form that we see in the definition. So it has to be of the form Cn x minus a to the n. And if we write out this series, n from 0 to infinity, Cn x minus a to the n, we see that the first term is just a constant, C0. The second term is a constant times x minus a to the first power. Then we have another constant times x minus a to the second power, then another constant and x minus a to the third power, and so on and so on. And so C0, C1, and C2 is just a sequence of real numbers, constants, and x is our independent variable. And Taylor series is a special type of power series. So one common example of a power series is a Taylor series. So for example, the series that we saw in example 1, n from 0 to infinity, 2 to the n, x to the n divided by n factorial, that is a power series. So this is a power series. Where we have Cn, the constant in each term is 2 to the n over n factorial. All of this. And then we also can write down what a is. And in our case, it's 0, because we just have x to the n, and you can think of that as x minus 0 to the n. So a is equal to 0. So that's really all a power series is. It's a function that can be written in terms of a series of this particular form. Now, when does a power series converge? That's what is going to keep us occupied for the rest of this section. There are 3 different things that can happen. So we are going to consider a power series of this form, and the set of all x values for which this series converges is called the interval of convergence. Of the power series. And for such a series, there are 3 things that can possibly happen depending on the particular type of series. The series can converge only at one point. That's one possibility. So only at the point x equals a. So only when we plug in x equals a. And you can imagine when you plug in x equals a, each term in the series would become 0. And so, yeah, every series is going to converge at x equals a, but it could be that that is the only point where it converges. In example 1, we saw the second case. We saw a series that converged for all values of x. So that, if you remember example 1, that was the case. And so we can draw that as just the entire real line gives us x values for which the series converges. So that is the second case. And then the third case is that for a certain values close to a in both directions, our series converges. So if we go p units out away from a to the left and to the right, our series converges. So we can write that as x minus a in absolute value is less than p. And so then that is our interval of convergence. So in this case, our interval of convergence is from a minus p to a plus p. And then we also have to check out what happens exactly at the endpoints of this interval. But if you're outside of that interval, then the series diverges. So for values within P that I'm drawing in right here in green, we would get convergence. And for values that are further away than P, we would get divergence. Okay, so one more note. What happens at the endpoints? So to find the interval of convergence of a power series, we apply the ratio test to figure out the value of P. And then we have to use other convergence tests to figure out the convergence at the endpoints of the interval. So in my picture right here, this is one endpoint, this is the other endpoint. And the question is, do I get convergence there at these endpoints? So for that, we have to use some other convergence tests. One final note, the value P sometimes is called the radius of convergence. So P is called the radius of convergence. We are not going to use that very much in our workbook, but if you watch other videos, you may come across those terms sometimes. All right, so the next few videos are going to show some examples where actually finding the interval of convergence for a specific series.